Good morning, everyone. I am Cyrille Gautier, Senior Power Electronics Research Engineer at SAFRAN SAFRAN Group Corporate Research Center. The subject of my talk is the use of gamma technology PowerForge to do preliminary studies on static power converters. My presentation will be in 4 parts. In the first part, I will rapidly introduce SAFRAN. Then, in the second part, I will introduce certain development planned for the decarbonization of aviation and present what could be the main characteristics of a next-generation aircraft electric network. The third part of this presentation is on the pre-design study of a 100 kW class active rectifier using PowerForge. At first, I will present the main hypotheses, and then I will analyze the design results. And finally, the conclusion. SAFRAN is an international high-technology group. I will not detail the figures presented on this slide, just to say that SAFRAN is one of the few companies that manufactures aircraft engines. The majority of these engines are designed and manufactured in collaboration with GE Aviation in the CFM joint venture. We can mention the CFM 56 and the LEAP engine. SAFRAN dedicates a significant part of its budget to research and technology. SAFRAN is SAFRAN Corporate Research Center created 6 years ago. Its main goal is to answer R&D and long-term innovation, mostly on technology readiness level from 2 to 4. SAFRAN seeks to improve its competitiveness in its high-technology markets by increase its capacity to ensure long-term innovations through upstream research, foster transversality between the different businesses of the group. I am part of the electrical and electronic system teams. Our work is on power electric systems in order to increase technology maturity from more electric aircraft and electrical hybrid propulsion. Our work is organized along 5 axes: electric network architecture, electric machine, power electronics converter and power modules, electromagnetic compatibility and lighting, high voltage and related physical phenomena. So, what are we talking about? Electric network of next generation aircraft, let's say 2030 plus, will depend on electric power increase and choices on more electric aircraft and more electric propulsion solutions. Decarbonization of aviation is the driving force behind the move toward more electric aircraft and increase in machine electric power. Sustainable aviation fuel is the other major measure for next-generation aircraft. The objective is the 80% improvement in energy efficiency since the start of commercial aviation. In 2030-2035, small electric aircraft and hybrid regional aircraft are planned. Also, new air mobility is another aspect for the electrification of vertical and takeoff and landing on small aircrafts. In 2050, large aircraft are planned to have zero emission and high electric power embedded. On this slide, we can see the NASA 2016 timeline of machine power with application to aircraft class. It seems quite optimistic, especially on the rise in very strong power. In more recent reports, NASA puts less emphasis on such high levels of electrification, but we have to study the implications of an onboard electric power of 10 MW. Airbus, for its part, rather presented a strategy based on hydrogen, zero-emission project, also involving hybrid electric propulsion. So, what could be the future of aircraft electrical network architecture? The legacy on single-aisle aircrafts is 115 volts AC current with a fixed frequency of 400 Hz. On more recent aircrafts, we found 115 volt AC and 230 volt AC wide frequency networks. Concerning DC networks, we can talk about 270 volt DC on A-35 military aircraft, and Airbus studies on HVDC 540 volts DC through Clean Sky European project.